In last video, we discussed about the Rutherford's atomic model, and according to Rutherford's theory, at the center of atom there is a nucleus and electrons are revolving around the nucleus. Now next atomic model, that is Bohr's atomic model. In order to overcome the drawbacks of Rutherford's atomic model for atom and to explain the line spectrum of the hydrogen, Niels Bohr in the year 1913 proposed a new model of atom which is based upon the Planck's quantum theory. And the main postulates of Bohr's atomic model are: one important postulate is an atom consists of a small, heavy, positively charged nucleus at the center of atom, and the electrons revolve around the nucleus in a circular orbits. So at center there is a nucleus and electrons are revolving around the nucleus in a specific orbits. For example, this is the nucleus, this is the first orbit, it is denoted by K, n is equal to 1. For K, n is equal to 1, n is a principal quantum number. This is the second orbit, it is L, principal quantum number is 2. This is third orbit, that is M, where n is equal to 3. This is N, this is the fourth orbit, n is equal to 4. In this way, at center there is a nucleus and there are orbits, okay, and electrons present in these orbits, and in orbits, various orbits, electrons revolve around the nucleus. So this is first postulate. Now second postulate is, as long as the electron stays in a given orbit, an electron does not radiate energy. These orbits are thus called stationary energy levels, and the energies of different stationary states or energy levels, it is given by En is equal to minus 2 pi square m e raised to 4 n square h square, where this m is mass of electron, which is 0.00055 atomic mass unit, E is a charge on electron, h is Planck's constant, n is principal quantum number, pi itself it is a constant, and this is the energy of electron or energy of any given orbit. Now the energy of various orbits are in the order that the K orbit has the lower energy than the L orbit. L orbit has slightly higher energy than K orbit, and in this way energy of orbit increases as electron goes away from the nucleus. It means N orbit has highest energy and here K orbit has lowest energy. So in this way energy increases from K, L, M to N and so on. Now again, third postulate is, when electron jumps from one energy level to another energy level, a quantum of energy gets evolved or absorbed, and there is a quantization of energy. Actually, energy of first orbit is suppose E1, or second orbit suppose it is E2, E3, E4. Now when electron jumps from L orbit to K orbit, then there is a emission of energy. That particular electron emits energy, and the energy difference, that is E2 minus E1, that energy will be emitted during the jump of electron from higher orbit to lower orbit. So this is the third postulate. Energy of electron is quantized. It means it increases or decreases in multiple of some constant energy. it is called as quantized, and this constant energy or quanta, it is h nu or delta E. So energy is absorbed or evolved when electron jumps from one state to other, and this energy delta E, it is equal to E2 minus E1. And then next possibility is the angular momentum of electron revolving around the nucleus is an integral multiple of h upon 2 pi. H upon 2 pi. It means angular momentum of electron is quantized. So similar to energy, angular momentum of an electron is also quantized, like h upon 2 pi or h upon pi, 3h upon 2 pi, 4h upon 2 pi, and so on. So similar to energy, angular momentum is also quantized. So these are the some postulates of Bohr's atomic model. Now what is the use or importance of Bohr's atomic model? According to Bohr's model, an electron cannot lose energy as long as it stays in a particular orbit, and therefore it explains the stability of atom. Secondly, Bohr's theory explains the line spectrum of hydrogen or helium plus or lithium 2 plus or beryllium 3 plus. All these species contain one electron. So Bohr's atomic model explains the line spectrum of the species containing one electron. This is another importance of Bohr's model. Bohr's atomic model helpful for the calculation of radius of orbit, and this is the formula for the radius. R is equal to radius of orbit, it is equal to n square h square upon 4 pi square m z e raised to 4, and this is equal to 0.529. Actually all these are constants except this n square. So it is equal to 0.529 into n square angstrom. For example, when n is equal to 1, radius of orbit is 0.529. When it is 2, radius will be, as per this formula, radius will be 2.116 angstrom. So just you substitute the value of n and you will get the value for this radius. So as we go away from the nucleus, radius of orbit increases. So this is another importance. With the help of Bohr's atomic model, it is possible to calculate radius of orbit. Next importance is Bohr's model helps for the calculation of energy of orbit, and this is the formula for the energy. En is equal to minus 2 pi square m e raised to 4 n square h square. Now what are the drawbacks of Bohr's atomic model? Bohr's atomic model is unable to explain spectra of multi-electronic atoms. Only it is applicable to, or only it explains the line spectrum of species containing one electron, but it fails to explain the line spectrum of multi-electronic atoms, or atoms containing more than one electrons, 2, 3, 4, like that. In practice, there are several atoms which contain more than one electrons, and Bohr's atomic model could not explain spectra of these multi-electron atoms. It unable to explain Zeeman effect, and Zeeman effect means splitting of spectral lines under the influence of magnetic field. It is called a Zeeman effect. As well as Bohr's atomic model unable to explain Stark effect, and Stark effect means the splitting of spectral lines under the influence of electric field. It is called as Stark effect. Bohr's atomic model unable to explain Zeeman as well as Stark effect. Then next is Bohr's atomic model unable to explain the hyperfine spectrum. And this is what is the hyperfine spectrum. It gives, actually main lines are further splitted into fine lines. It is called as hyperfine spectrum. This is actually line spectrum of hydrogen. Actually, according to Bohr's atomic model, there should be few lines in the hydrogen spectrum, but each line further split into several fine lines. This is called as hyperfine spectrum, and this hyperfine spectrum could not explained by Bohr's atomic model or Bohr's atomic theory. Next is Bohr's atomic model unable to explain three-dimensional nature of atom. Bohr's atomic model further unable to explain de Broglie concept and Heisenberg uncertainty principle. Heisenberg uncertainty principle. And according to de Broglie principle, and the particle has a dual nature, that is wave nature and particle nature. This cannot be explained on the basis of Bohr's atomic model. Even the Heisenberg principle, it is unable to explain on the basis of Bohr's atomic model. According to Heisenberg uncertainty principle, it is not possible to measure simultaneously both the position and velocity or momentum of microscopic particle with absolute accuracy or certainty. This is the Heisenberg uncertainty principle, and for this Heisenberg uncertainty principle, the correct reason was not provided by Bohr's atomic model. So these are some drawbacks of Bohr's atomic model. Bohr's atomic model unable to explain the spectra for multi-electron atoms. It unable to explain Zeeman effect, Stark effect, hyperfine nature of the spectrum, why there is a splitting of main lines into sublines. This was not explained in Bohr's atomic model. In hydrogen, hydrogen's emission spectrum of hydrogen, there are actually 5 series of lines: Lyman, Balmer, Paschen, Brackett and Fund. But each line further split into several lines. Look at this, the lines of Lyman series. There are several lines. Why for Lyman series there are several lines? Explanation for this was not provided. Okay, so this is about the Bohr's atomic model. So here the Bohr's atomic model is somehow superior than the Rutherford's atomic model, because in Rutherford's atomic model only it was considered that at center there is a nucleus and electrons are revolving around the nucleus. But in Bohr's atomic model, somehow further explanation is provided, that is, not only electrons revolve around the nucleus, but they revolve in a specific orbit, and orbits are designated as K, L, M, N, etc. And as electron goes away from the nucleus, its energy increases. So these are the additional things or additional concepts explained by Bohr's atomic model.